Around the world, millions of people live far away from medical help. In emergencies like choking, severe burns, or heavy bleeding, the difference between life and death can come down to just a few minutes. But what happens when you have no internet, no signal, and no time to search for help? That's where MedPal comes in. Your offline, privacy first medical assistant, which is powered by Google's cutting edge Gemma 3N model. It runs entirely on your device, ready to guide you through emergencies, first aid, and essential healthcare decisions anytime, anywhere.
Hi, so this is a small demo of what I have built. I will be disabling all forms of external connectivity, so this thing will be running completely offline. This is a small message which is similar to what kind of a problem a person may be facing during his real life. The message is sent. This message is sent to my FastAPI backend. The backend will process it and then send back a response. This may take from around 1 to 2 minutes depending on the context and the length of the message sent. The code is completely written in a segregated backend and frontend way. The backend is primarily a fast API backend which has multiple endpoints depending on the kind of query that is being sent. The the audio which is sent is then taken into a whisper model. Then the model then converts it into a string to send it to the Gemma 3N. The Gemma is being run on Ollama. I am using it to do on-device inference. This is completely an offline process. It is completely safe and secure. As well, it does not need any internet connectivity. This thing, the Ollama model which I am running offline, um, is being accessed by the fast API through an API endpoint call. This is the response it will send back. So this is a this kind of a reaction tells this kind of an instruction helps the person decide how to respond to his problem and decide what to do. It also has a voice feature. Hi, I fell down and I have bruised my hand. This then sends the entire voice to whispered, which encodes it and sends to Ollama. The Gemma 3N model helps to do a very efficient and low resource uh, encoding of low resource inference. This can be done on very light devices. It helps to do it at a very economic scale. It can be done on very lower end devices which rural people have, and this helps a lot in cases of emergency where there is very low medical support available nearby. So this is a sample of how it works. It gives a transcript of what the person said, and then it gives the entire reaction and the entire response. It tells how to react, it tells what kind of an response the person should take, and it also asks follow-up questions which help a person decide and analyze what to do. The front end code is written in Vue. I am using Vite and Tori. I'm using it as an optional element which I can use it to create um, Android or iOS apps which will help me to package and send it out. Thank you.
MedPal is more than an app, it's a lifeline. Whether you are in a remote village, traveling off grid, or facing a sudden crisis in the comfort of your house, it delivers instant, reliable, and private guidance without relying on the internet or any other external source. Built for the Google Gemma 3N challenge, MedPal showcases the power of on-device AI for real-world impact. Life-saving answers anytime, anywhere. That's our mission. Thank you for giving me this opportunity to present this.